Thanks, Dr. Jayashree. Good morning, everybody. I'm Dr. Gurjeet, and I'm going to present on role of slit scanning imaging system, that is Orbscan II. In my presentation, I will be stressing upon how to read a quad map, which is a typical map of Orbscan, and we'll be discussing about the various 10 red flag signs, which every refractive surgeon should be knowing in order to rule out a case which has to be taken for refractive surgery or not, so that he doesn't land up into a post-refractive surgery ectasia. So very important for that. I don't have any financial disclosure. Orbscan is a technique which is taking care of two technologies. One is a slit scanning system, one is a Placido disc system. So there are about 20 slits to the right, 20 slits to the left, which move upon area of 3 to 5 millimeter area, and they cover about 240 data per slit. There is a Placido disc also there, which has about 40 rings, and which has about 40 rings and captures about 9,000 data area. So Orbscan is a multi-dimensional technology. How? Because it integrates multiple disparate technologies, that is a slit scanning system and a reflective system. It measures multiple ocular surfaces ranging from the anterior cornea to the posterior cornea to the anterior iris to the anterior lens. So complete anterior chamber parameters. It displays multiple and complete mathematical surfaces, taking care and displaying curvature map, power map, elevation map, and the thickness map, which is very important for a refractive surgeon. So it measures the surface elevation directly by means of a triangulation of the back scattered slit beam. So it uses a triangulation system by which it captures the anterior to the posterior surface of the cornea. It measures the surface slope directly by means of a specular reflection, which is typically used in a Placido-based system. Then it unifies both this system to obtain accurate surfaces in elevation, slope, and curvature. Now this is a typical quad map of Orbscan. Quad map because it has 4 maps. One is the anterior elevation map, one is the posterior elevation map, the thickness map or the pachymetric map, and the keratometric map or the axial map. So we will be discussing all these maps which a refractive surgeon must be knowing, so that he is able to rule out the cases which are not fit for the refractive surgery. And this is a central gray area which has various indices. So we will be discussing all these parameters in detail. The first is this gray area. So what does this shows? It has these values: sim k value, k1 and k2 value with the corresponding axis. So what is basically sim k value? Sim k value is the orthogonal curvature at the central 3 millimeter zone area. So basically this is a central 3 millimeter standard k value, which has been derived by using a special formula, and those two other are the k1 and the k2 value with the steep and the flatter axis. Along with that, this has a 3 millimeter zone area and 5 millimeter zone area with the irregularity index here. Irregularity means what is the irregularity in the 3 millimeter. This is specifically important for a keratoconus case or in case of irregular cornea. So it has these corresponding values, like in the 3 millimeter zone area, the irregularity is about 1.2, and in the 5 millimeter it is 1.3. Then it has this horizontal white to white diameter, which is about 11.6, which is specifically used for ICL planning. Then pupil diameter 3.5 millimeter, again important for the scotopic pupil measurement. The thinnest pachy, the thinnest point, what is the pachy there? 5.36 with the corresponding X and Y orientation. Then what is the ACD? Again important for the pachychial planning. Then kappa value. What is the kappa value? These all values are important from a refractive perspective. So the other map is the posterior elevation map. This rounded area shows what is the posterior elevation from the best fit sphere. This is the value, like this is the 30 over there. And there are corresponding colors also to show this. As Dr. Jayashree already discussed, the Louisiana scale which is used. So this is the value there. And this above map, this above value is the best fit sphere which has been utilized for this map. So here the best fit sphere value is 6.15 millimeter, and this is the corresponding K value for this. So we should be knowing all these indices which we'll be utilizing for our refractive practice. Now these are the various patterns which are seen on the posterior float map. One is the complete positive band or the ridge pattern, which is seen in the maximum number of the cases. Incomplete ridge pattern, butterfly wing pattern, and the central island pattern. The importance of this is a map which has to be remembered for a ectatic condition. So what is that central hill pattern? As you know that the cornea is prolate in shape, means the curvature decreases from center to the periphery as we go to the periphery. So that is why the center part which lies above the reference sphere is seen as a central hill pattern. As can be seen in this figure, this central part is standing above the best width sphere. So that is why this is seen with the red area. As we go to the periphery, this dips down below the reference plane. So this is seen as the annular C area, here denoted by the blue color. So the color intensity is varying there. Then again, as it goes to the periphery, it again rises above the best width sphere, these central islands, and these are known as the peripheral islands. So this is the central hill pattern seen on the posterior float map. Now, as we know that the regular astigmatic cornea as a toric surface means there are two axes. One is the steeper, one is the flatter axis. So there will be two axes. The sharper will fall below the reference sphere and the flat will lie above the reference sphere. So we have this typical saddle pattern where one axis will be rising above and the other will, the corresponding 90-degree axis will be falling down in the corresponding perpendicular axis. So this is the saddle pattern which is seen. Now the third map is the anterior elevation map. So that will be showing how the anterior, the part of the cornea is elevated. Now this value shows the anterior elevation here. Can be seen here. This is 0. So it is almost at the center. And this, the above rounded value shows the best width sphere value and the corresponding K value. This is the third map, which is the axial or the keratometric map. As the name suggests, the keratometric means all the K values there. So this map is showing a bow tie pattern, which is actually a axial artifact, because this happens to be because of the central intersection of the meridional plane, as seen in this. This is with the rule astigmatism map. Now the various patterns which are seen on a keratometric map are, this is the common patterns which are seen on which surgeon or a refractive person will be seeing. This is the round pattern. These are the oval pattern which can be superiorly placed or inferiorly placed. These are the symmetric bow tie pattern, as this is a bow tie pattern here. This is the asymmetric bow tie pattern here. This is the irregular pattern seen in the irregular astigmatism part. And these are the three maps or the keratometric maps which every refractive surgeon should be knowing, as these are the asymmetric patterns which are indicator of, which can be seen in a forme-fruste keratoconus or a keratoconus, which are absolute contraindication for the refractive surgery. So be aware of all these three maps. Now when we join the axis over there in the K map, so we get these radial axes, as can be seen. This is the asymmetric bow tie pattern, and when we join the axis there, we are seeing that the angle which is being created here is almost like 21 degree. We will be discussing in the corresponding slide what is the importance of this. So this shows, this is known as skewing of the radial axis. So the radial axes are skewed. Now this is the pachymetric map or the thickness map, which will be giving the value in the central 3 mm zone area, in the 5 mm and the corresponding 7 mm zone area, which are important for the refractive practice. So now we have discussed all the 4 maps of the Orbscan. Orbscan has number of applications in refractive surgery and in the cornea practice. So what are the applications? First is the pre-Lasik evaluation, as it is a corneal tomography technique. So we will be using it for the evaluation purpose, where it will be giving us the K1 and the K2 value, and it will be giving us the thinnest pachy. So these are the values which are to be fed into the machine in order to do our refractive surgery. So K1 and K2 values are given, and these are the colors. In cornea practice, we need to know about early keratoconus, which is seen in the central hill pattern here, as can be seen here on the posterior float as well as on the anterior float. And this is the keratometric map, which will be giving us the K1 and K2 value. You can see they are on a very higher side. Advanced keratoconus, as seen in this case, this is a pellucid marginal degeneration, which is showing the typical kissing bird pattern seen, and the inferior ectasia there. for the intact planning, where we will be deciding about where to place our incision there. So that is also done. Now, what do you mean by the red flag signs? As this sign displays that this is a warning sign for the refractive surgeon, as he should be knowing all these signs in order to say a complete note to a person, that that you are not suitable for the refractive surgery. Now, what are these? Now, according to Rabinowitz index, the K value if greater than 47.2 is a red flag sign. Similarly, the asymmetry between the two eyes of greater than 0.92 diopter is a red flag sign. Now, second red flag sign, the inferior superior value, the difference between the 5 superior and inferior point, if it is greater than 1.2, is a indicator of formation keratoconus. Now, Orbscan Pachy, if less than 470, should make the refractive surgeon aware of the case. And similarly, if you subtract the thinnest Pachy here, like here it is 543, from the thickest Pachy and the 7 mm zone area, if it is greater than 100, then this is a red flag sign. Now, posterior float, if greater than 51, is indicator of primary posterior corneal elevation, and if greater than 55 is an indicator of formal frustrated keratoconus. The A to P value, the anterior to posterior difference value, if the ratio is greater than 1.21, is indicator of formal frustrated keratoconus. Anterior float value greater than 16 micron, again one of the red flag sign. Irregularity index already we discussed in the 3 mm zone area if greater than 1.5, and in the 5 mm zone area if greater than 2.5 is indicator of irregular astigmatism or higher order aberration. SRX we already discussed, greater than 21 is a red flag sign. So all these 10 red flag signs should be known by a refractive surgeon, as if he see one abnormal man, he should be cautious about that. If 2 abnormal man, he should be concerned, and if 3 abnormal man, it's a contraindication. Now, this is one of the case walking into the refractive surgery clinic with a refractive value of -4 with -1.25 at 40 degree, with normal K values 41 and 40.8, and normal corneal thickness, had a residual bed of 310 also. But something was missed in this case, that is why this case landed into this post-Lasik ectasia. What was missed in these cases? One was, if you see here clearly that the thinnest Pachy here is 504, and if you subtract it from 7 mm zone area, the difference was 121. So this was one of the red flag sign. If you see here posterior elevation, this was in the range of 35 to 40 with the central island pattern, indicative of a formal frustrated keratoconus. So again, one of the red flag sign. If you compare the anterior to the posterior ratio, it was about 1.23, again greater than 1.21, a red flag sign here. If you see the radial axis here, the skewing was about 34, there was a asymmetric bow tie pattern, and the inferior superior value was 1.1. So we had almost 7 red flag signs, that is why the patient landed into post-Lasik ectasia. As with any other technology, Orbscan also has limitation, as Orbscan always gives a higher posterior elevation map, which can be showing false post-Lasik ectasia. Orbscan shows poor repeatability in terms of posterior elevation, and the repeatability and the reproducibility of the total corneal power is higher with the pentacam than with the Orbscan. So that is the part which lacks with its counterpart. In normal cornea, Orbscan usually produces the pachymetric value greater than 30 mm. That is, it overestimates thicker cornea, underestimates thin cornea. It has general tendency to measure under measure the thickness by 37 micron as compared to ultrasound post-Lasik case. To improve this, the linear acoustic meter of 0.92 was introduced, which reduces the pachymetry, but this also didn't solve the purpose. So with any other, even though it has lot of advantages, but limitations are still there. Thank you for the patience listening.